Today I'm going to show you how to use multiple regression in Excel, and I apologize for my voice. This is problem 13.5. In another video tape I already showed you how to use TV ads to estimate weekly gross revenues. Tonight we're going to show you whether newspaper ads. First, let's do a simple regression and see how good does newspaper advertising do. Let's go ahead and use the data analysis tool pack. We're going to use regression. I'll start from scratch here. For the Y range, we have to input the variable that is to be predicted. That's our dependent variable. For our independent variable, I'm using this as a simple regression. I'm going to put newspaper advertising. Since I have labels, cells, I will click the labels box and check it off. And for output, I'm going to put this cell right here. If I dump the results out, you will see that the R squared is very, very low, 0.0004. That's 4%. That means 4% of variation or variability in weekly gross revenues is explained by newspaper advertising. So even though we have a regression equation that has been calculated for us, which can be written as y hat equals 93.9 minus, notice the minus sign, 0.043 times newspaper ads, ad dollars. Even though that's our equation, we really don't want to ever use that because the goodness of the fit is so bad. Now let's go back and review part A, in which we looked at television ads. When we use television ads to estimate gross weekly revenues, our R squared was 65%. So that's much better. And we say 65% of variation in revenues is explained by TV ads, but that essentially means that 35% is explained by other independent variables. So what we should do, let's go back to the data. Let's go ahead and see if our goodness of fit improves any if we use multiple regression and use both of these advertising variables to estimate revenues. We'll go to data analysis tool pack again. My dependent variable is highlighted already, but for my independent variables, now I will highlight both columns. Please pay attention when you use Excel, multiple regression, your independent variables must be in adjacent or contiguous columns. If you're working with a data set where the columns of independent variables, the columns for your X variables, are apart from each other, you must cut and paste them into fields that are adjacent to each other so that then you can come and highlight them just like I did now. We have labels in all of these fields that I selected, so I'm going to keep the labels box checked off. And for output range, let's go ahead and dump the results of the multiple regression, let's say over here. You will see that our R squared is 0.92, but because we're using multiple regression, we must use the adjusted R squared to make our interpretation of percentage or of the goodness of fit. All of this result right here and some highlighted interpretations are on this tab in part B. So let's review it here. Here is our regression result, or our equation. Intercept is 83.2. Slope coefficient for TV ads is 2.3 rounded, and slope coefficient for newspaper ads is 1.3 rounded. So you can write your regression equation as you see here. And in fact, I could go here and say that my X1 really is, my X1 really is TV ads, and my X2 really is paper ads. And that'll be more like my regression equation that I will be working with. Oh, I see. Dr. J needs to go to bed. It's 4 o'clock in the morning. There. So now you can see the regression equation. Notice that when we were working with newspaper ads as the predictor, coefficient of determination was only 4%. When we were working with new TV ads as the predictor, coefficient of determination is 65%. And now that we're working with multiple regression, the coefficient of determination is almost 89%. So this is much better, and that means that only 11% of variability in revenues can be explained by other variables that are not included in this regression analysis. I think that's all I have to say on this. Thank you.